The interstellar object 3I/Atlas has been doing very strange things from the moment it first entered our solar system. And these things continue to change and evolve as it begins to make its way out of the solar system, as it closes on what is perhaps its last significant encounter, and that is with Jupiter in a mere 10 days from the time of this recording. There's a lot of speculation going on as to what is going to happen when this object comes under Jupiter's gravitational influence. Will it come under this influence at all? Will it pass Jupiter by still under the Sun's gravitational influence, and therefore nothing will really change about its trajectory? Or is it going to come close enough to where Jupiter's gravity will start having an effect on it? And more importantly, do we even really know where 3I/Atlas is going with any accuracy? NASA JPL thought that they were very clear on this object trajectory given both its gravitational acceleration, that is to say, its new trajectory after its close encounter with the Sun based on the influence of the Sun's gravity, and what's called non-gravitational acceleration caused by cometary outgassing. It was thought that these things were understood, and JPL was plotting its course based on that understanding. But now it has become clear that NASA wasn't right about what was called the NGA, or non-gravitational acceleration. A recently released paper studying 3I/Atlas's location over the last several months based on hundreds of observations has determined conclusively that NASA was not right about this object's velocity, trajectory, and acceleration. And even though the difference is not enormous, it might be enough to put this object into Jupiter's gravitational influence, which will change where it's going completely. Good afternoon, alien enthusiasts, and welcome to another Angry Alien Bulletin. Today, once again, talking about 3I/Atlas. Even though this topic is really losing a great deal of popularity in the general public, not many people are talking about it. The media definitely isn't talking about it, at least not to any great degree. But things continue to happen with this object, and definitely new discoveries continue to be made, particularly right now in regards to the object trajectory to its so-called NGA, or non-gravitational acceleration. Let me go ahead and give you a quick review of what we're talking about here. Any object moving through the solar system is going to come under the influence of the various gravitational bodies that exist in the solar system. The vast majority of that influence, of course, comes from the Sun, whose gravitational pull is far more powerful than all the rest of the planets in the solar system combined. And then you have objects, of course, like Jupiter that wield a considerable amount of influence as well, at least in proximity to the planet, and Saturn, etc., going all the way down even to the tiniest asteroids. Even these tiny objects wield a little bit of gravitational influence, although not much. If you compare, for example, the amount of influence that Jupiter has on me versus the amount of gravitational influence that I might have on this can of soda. Believe it or not, I wield far more gravitational influence on this can of soda than the planet Jupiter has on it. And that's all because of distance. Just to give you an idea of how big the difference is between the distance between me and this can of soda, and then the distance between the soda and Jupiter, and all that makes a big difference. And so therefore there are many objects in the solar system that really don't have much influence on 3I/Atlas at all, although the Sun definitely does. And then any sort of adjustment, any sort of course change or speed change, acceleration, that sort of thing that cannot be accounted for by gravitational force alone is called NGA, non-gravitational acceleration, and this generally only happens with comets. Comets being blocks of ice that have explosive outgassing caused by the Sun's heat shining down on them, where ice turns to steam, and the steam experiencing an explosive release from the surface of the comet provides acceleration and movement. Kind of like a rocket engine. Not nearly as powerful as a rocket engine. A rocket engine has roughly 4,500 meters per second worth of velocity associated with it, whereas explosive outgassing is a few hundred meters per second. So we're talking maybe 1/10 or 1/9 of the influence, something along those lines. But still it can provide a substantial amount of shift to an object's trajectory. A comet's trajectory, that is. And we thought we had it locked down with 3I/Atlas. We thought we understood how much of an influence non-gravitational acceleration was having on this object, and it seemed to put it very much within the range the upper range anyway of traditional comets. However, a paper that just came out has determined that NASA was wrong about the estimates when it came to NGA. Not necessarily in terms of the amount of non-gravitational acceleration that the object was experiencing, but proportionally how much of that acceleration was taking it away from the sun, or was it slowing it down? That sort of thing. The nature of the acceleration is wrong. What that means is that 3I/Atlas may not be going where NASA thought it was going. And if it passes the Hill radius of Jupiter, if it passes into the gravitational influence of the largest planet in the solar system, its trajectory will change even further. So 2 days ago, a newspaper reported the most comprehensive analysis of the non-gravitational acceleration, heretofore referred to as NGA, of the interstellar object 3I/Atlas, and its results are very different from the official NASA report posted on the Jet Propulsion Laboratory Small Body Report. Whereas NASA reports a radial acceleration component away from the sun that is 5 times larger than the tangential component along the direction of motion of 3I/Atlas. The new paper derives similar amplitudes for the radial and tangential components. What that suggests is that 3I/Atlas is being pushed sideways and not simply away from the sun. That actually is not the direction that 3I/Atlas should be going if it were purely under the influence of traditional cometary outgassing, because cometary outgassing happens on the side of the comet that faces the sun. Therefore, the side that's being warmed by the sun. And so, the vast majority of non-gravitational acceleration should come from the radial acceleration component away from the sun rather than a balance between the two. If you're confused by that, think of your rocket engines pushing you away from the sun simply because the sun is your launch pad. If non-gravitational acceleration is being caused by cometary outgassing, which is being caused by the sun is sort of the launch pad for your rocket, or at least it should be. And that is not actually the case. The object is being pushed sideways. And if it's being pushed sideways away from the sun, that means it's coming closer to Jupiter. Not a whole lot closer, but still potentially hundreds of thousands of kilometers, which could make a very big difference as we are about to see. So yeah, official statements from NASA can be wrong, and science is a learning experience. Now, according to Avi Loeb, does a large non-radial acceleration make sense? Well, yes. Observations from August of 2025, when 3I/Atlas was approaching the sun, reported the existence of collimated high-latitude jets that displayed a periodic wobble consistent with nucleus rotation. This morphology indicated localized sources of mass loss rather than uniform sublimation of the nucleus, which could trigger significant non-radial acceleration. In 2 papers that Avi Loeb co-authored with Tony Scarato, they removed the circular glow around the nucleus in the highest resolution post-perihelion images of 3I/Atlas from the Hubble Space Telescope and discovered 3 symmetrically separated mini-jets in addition to a prominent sunward anti-tail modulated by a 7.1-hour rotational period and consistent with a spin axis orientation within 20 degrees of the sunward direction. So that means there's a wobble relative to the poles of the object as it's rotating, and it had these 3 symmetrical jets. This configuration naturally favors strongly directional gas and dust emission capable of generating a transverse acceleration component, which is comparable in magnitude to a radial one. In other words, because these jets are so symmetrical, that would create a proportional acceleration both in terms of transverse and radial acceleration. Makes sense. Then again, that's not very consistent with traditional cometary outgassing. It bears a greater resemblance to an object under artificial control. Now, the total magnitude of this difference is very small, only about a micrometer, which is a percentage of the width of a human hair per second squared. But over the course of a month, this results in an offset of a few thousand km. And given how close 3I/Atlas is coming to the Hill radius of Jupiter, that few thousand kilometers could actually put under the influence of Jupiter's gravity, or perhaps a direct interception of Jupiter's Hill radius. What would that mean? Okay, so that's what's been discovered in regards to the non-gravitational acceleration aspect. But what might happen if 3I/Atlas were to come within Jupiter's sphere of influence? Or what happens if it actually clips the so-called Hill radius? If it's not under the influence of either the Sun's gravity or Jupiter's gravity, what happens then? Okay, so we're going to venture into the speculative here. Really deep into the speculative. First of all, a lot of people are talking about the possibility of 3I/Atlas becoming a new moon for Jupiter, getting captured by Jupiter's gravity, and then slingshotting around and coming back towards Earth, that sort of thing. What would it take for that to actually happen? Well, let's say it came just to the edge of the Hill sphere, just barely passed inside it, which its current trajectory might allow it to do. Then the escape velocity from Jupiter is still pretty low, 2.2 kilometers per second, meaning that you would have to adjust this object's trajectory by about 58 kilometers per second given its current path. So also let's talk about how much this thing weighs. We think that 3I/Atlas is about 2.6 kilometers in diameter. That means that it weighs about 9.2 billion tons. That's a fairly accurate estimate. If it's comprised mostly of ice, if it were hollow or something, that would definitely reduce its mass. But we're still talking an enormous amount of energy here. To slow something that heavy down that much would require 1.66 times 10 to the 22nd power joules. In other words, over 16 billion trillion watts for 1 second. That is, and a much, much longer time for a less powerful power plant. This is an enormous amount of energy, roughly the equivalent of the total energy output of the sun for 40 to 50 seconds or thousands of times the annual human energy consumption. Just seems absolutely impossible. Even antimatter would have a hard time creating that much energy. Now, if we were talking about something that was going as fast as ʻOumuamua, it drops down to about 2.8 by 10 to the 21st power joules. That's still a ridiculously immense amount of energy. If we're talking about something very, very heavy, it requires an enormous amount of energy to change its velocity and trajectory by a lot. In other words, enough to get captured by Jupiter's gravity. 3I/Atlas is just going too fast. But what if it were to deploy a 10-ton probe of some kind instead? Something much smaller. Let's say that it used a mag sail or a photon sail of some kind, which means 3I/Atlas could provide the energy for it using an electromagnetic field or a very powerful laser to decelerate the probe. So the probe wouldn't have to carry a very powerful nuclear reactor or antimatter reactor or something on board. What would be required then? Well, for only 10 tons, the requirement is 1.88 times 10 to the 13th power joules. In other words, 18 trillion joules. That's still a lot, but a billion times less energy that is necessary to decelerate 3I/Atlas. So, even a conventional nuclear reactor can probably produce the necessary energy to decelerate a 10-ton probe that much, assuming you started saving up the energy ahead of time. But hold on for just a moment. Let's talk about next-generation propulsion systems. Godlike propulsion systems. And even though we call it godlike, it's actually well within our understanding of physics and engineering. What if 3I/Atlas's anti-tail were comprised of nanomachines? I've talked about this before. That can collect solar energy and beam that energy back to the nucleus as a power generator. An anti-tail of 700,000 kilometers to 1,000,000 km long. That much volume can actually absorb a tremendous amount of solar energy. Let's have a look at the numbers here. If the anti-tail were functioning as a Dyson swarm-like structure, that's what this would be called. And let's say that it only absorbs 10% of the solar energy that is striking it based on the anti-tail dimensions and the projected total area of the anti-tail, which is 10 to the 17th power square meters at 5 astronomical units away from the sun. This yields a power output of 1.1 by 10 to the 18th power watts. So accumulating the 1.66 by 10 to the 22nd power joules in order to capture 3I/Atlas would only take 4 hours. Think about that for a moment. This enormous amount of energy necessary to decelerate this colossal object to the extent necessary to be captured by Jupiter's gravity could be generated in 4 hours, assuming that 3I/Atlas's anti-tail is actually a Dyson swarm of some kind. And what if the Dyson swarm were to be struck by a coronal mass ejection? And by the way, We know that 3I/Atlas and its anti-tail has been struck by solar coronal mass ejection. Well, a CME can produce up to 5 by 10 to the 23rd power joules. And assuming that the tail could only gobble up about 10% of that, that's 5 by 10 to the 22nd power to 10 to the 23rd power joules per CME event. That's 3 to 6 times the amount of energy necessary to decelerate a 2.6-kilometer object down to the necessary speed to be captured by Jupiter's gravity, and it vastly exceeds by 9 to 10 orders of magnitude what is necessary to decelerate the probe. So in other words, if 3I/Atlas is the product of some sort of advanced civilization, and it has something like a Dyson swarm at its disposal, and again, this anti-tail has behaved very strangely and is capable of defying the solar wind in a way that no anti-tail has been able to do in the past. So who knows? It might be something like that. It would definitely be capable of producing the necessary energy. It's a bit humbling to think that an alien civilization with this kind of power at its disposal could do the sorts of things that thousands of our civilizations combined could not do. And then lastly, since we're talking about non-gravitational acceleration or explosive outgassing, assuming that's what's actually causing all of this, then what is also happening when it comes to the chemicals associated with 3I/Atlas? Its chemical composition, because very strange stuff is happening here. As 3I/Atlas was coming into the solar system, it was giving off some very, very identifiable and recognizable gases. There were certain gases that were identified fairly easily by spectrographic analysis. Carbon dioxide and carbon monoxide primarily, a little bit of water ice, but almost entirely carbon dioxide with a substantial amount of carbon monoxide as well. And now all of a sudden things have changed tremendously. And scientists think that they have an explanation for that. But actually the explanation doesn't hold water. Now I've discussed this topic before, but I've only quoted Avi Loeb as far as this strange anomaly is concerned. And instead what I'm going to do is quote from the paper that inspired Avi Loeb to start talking about this, entitled The Volatile Inventory of 3I/Atlas as Seen with the James Webb Space Telescope. Here's the problem. Before it made its close approach to the Sun, while it was still a considerable distance out, and James Webb took its first observations of this mysterious object, we only saw a couple of gases present, mostly carbon dioxide with some carbon monoxide and a little bit of water gas. Although the ratio of carbon dioxide to water was very, very lopsided, more so than any comet anyway that's ever been observed in the past. But things get even stranger when we talk about the methane. There was no methane at all. And by the way, methane is an organic chemical, one of many that we've seen from 3I/Atlas since it made its close approach to the Sun. But the methane showed up after it achieved perihelion. In addition to that, we also saw other organic chemicals such as cyanide. But the methane was the biggest mystery. And here's why. And again, I'm going to go ahead and quote from this paper rather than quoting Avi Loeb or trying to explain it myself. Quote, the delayed onset of CH4, which is methane. This production raises interesting questions regarding 3I's history. Solid phase methane is hypervolatile with a significantly lower sublimation temperature than CO2. Thermal modeling of airless bodies has demonstrated that methane ice at or near the surface of 3I/Atlas would have been vigorously sublimating at the time of the first reports of cometary activity during 3I's inbound track. However, neither the James Webb Space Telescope observations on August 6th of 2025 nor the Sphere-X telescope spectrometry from August 5th to August 15th of 2025 detected methane. These observations suggest that methane is depleted in the outermost layers and imply that 3I previously underwent a period of significant heating within its natal planetary system prior to its injection into the cold interstellar medium. In other words, all of the methane burned out of the exterior of the object. And then there was a reservoir of primordial CH4 residing at depth and was only activated after the thermal wave produced by 3I's perihelion passage. So the idea is there was no methane on the surface, and then when it made its close approach to the Sun, it cracked 3I/Atlas open, so to speak, and all of this methane inside was released. Here's the problem within this proposed scenario. The early detection of carbon monoxide outgassing on 3I presents an apparent quandary. Carbon monoxide is more volatile than methane and should have also been depleted from 3I's near surface. Yet a considerable amount was detected prior to methane. Now, the paper goes on to point out that there are some Kuiper belt objects that display these sorts of characteristics also, at least as far as carbon monoxide are concerned. Not as far as methane's concerned, but still the carbon monoxide seems to linger on the exterior of these objects in spite of long periods of radiation bombardment. So maybe 3I/Atlas is more like a Kuiper object than a comet, a traditional comet. But regardless, this is a very, very strange characteristic on top of a massive list of other strange characteristics. Why is this object producing organic chemicals only when it's about to make a close approach to a planet whose moons might be ideal places for life to spring up, at least in their deep subsurface oceans? Just one of many strange mysteries about this bizarre object. Mysteries that are not mentioned by the mainstream media, seldom talked about in the mainstream scientific community. But I hope you've enjoyed this video and my particular obsession with this topic and this incredible mystery that continues to make its way through the solar system and continues to provide us amazing anomalies to ponder on. I'd like to dedicate this video to Lissel, a very important person to David Hender, who is the most generous supporter of this channel that I've ever had. I deeply appreciate everything he's done for this channel. And again, this is dedicated to Lissel at his request. Thank you so much to both of you. Please don't forget to like and subscribe. If you'd like to support this channel in any way, all the details are in the description. And until next time, stay angry about space.